What's happening, everyone? Okay, so today's lesson is a little bit different from what we've been doing normally. Today, you've got this document with, I think it's 8 questions. They're all from the review exercise. And basically, what I'm going to ask you to do is just have a go at them, basically, and then we'll kind of see what needs to be looked at. And what I've done is I've tried to kind of put them together in little pairs of questions so that the same kind of issues that come up on question 6 may come up on question 7 as well, come up on this one, come up on this one. So you'll probably see that as we work through. Now, because this is quite a lot of work here, I'm going to do these in a little video. So this one is I'm just going to go through question 6. I'm then going to talk you through question 7, ask you to have a go at it, and then pause the video, and then I will go through that with you on this video as well. Okay. As always, if there are any issues with any of this stuff, you can just let me know. I've just realised I got the date wrong on that thing. I have. It should say 14th, that shouldn't it? Apologies. I haven't got a clue what day it is at the minute, I have to say. Right, so questions 6 and 7. I've put both of these in because these are differentiating with your sine and your cos and stuff like that. So it's just looking at how we do that. So let's have a little look at the question. These are very, very similar to exam questions. Remember, that's why I put them in. Given that a curve has equation y equals cos squared x plus sine x when x lies between 0 and 2 pi, find the coordinates of the stationary point. Right, so remember, stationary point, what does that mean? It means where the graph either bottoms out or tops out, or possibly a point of inflection, and it means effectively that dy by dx equals 0. So what that should be saying to you then is, okay, I need to differentiate this. I'm then going to set it equal to 0, and I'm going to solve. And then when I get those answers, remember those answers will be in terms of x. And because it wants coordinates, that means that I need the corresponding y values for that as well. Okay. Now, when you're kind of practicing questions like this, I don't know if any of you would know what that graph looks like, but it's a good idea to maybe just on Desmos go and put that in so that you can see how many turning points you are looking for. Okay, because it will be, and then at least then you can say if you can spot from looking at the graph that actually there are 4 stationary points. If I've only got 2 of them, I've done something wrong somewhere. So it might then just kind of help you with those little kind of trigger things that go off in your head. Think, hang on, this is wrong. I should be getting more than that. Just an idea. You don't need to do that. Okay, so the problem that obviously we've got here is this one. We can differentiate sine x. We know it's going to go to cos x. So the problem we're going to have is differentiating that when we get dy by dx, isn't it? Okay, so let's take the cos squared x over to this side and let's just differentiate that separately. Can you remember what rule we have to use when we're doing something like this? It's called the chain rule. It's where we let u equal cos x. So y will equal u squared. U will equal cos x. Differentiate both of these. So dy by du will equal 2u. And du by dx will equal, that'll go to minus sine x. And then we put everything together. So du is going to be 2 cos. Sorry, dy by du is going to be 2 cos. Du by dx is this. So when we differentiate cos squared, we're going to get minus 2 sine x cos x. And then when we differentiate the sine x, that will just go to plus cos x. Okay. So what we now do is set that equal to 0. So 0 equals minus 2 sine x cos x plus cos x. And we want to solve that equation now. Okay. So what we should be doing is, remember, at this point, you might look at that and think, I can divide by cos. Never, ever, ever, ever divide by a function. Never, ever cancel out something when you get to this stage. The reason for that is, basically what you want to do is factorize out the cos x, which means that the cos x will end up equaling 0. Now, cos x equals 0 will give you coordinates because we can solve that. It's not like when you could cancel out, say, a 5 from both terms or anything like that. If you cancel out a function, effectively what you're doing is you're going to cancel out a solution. Okay, so we're not might be tempting at this point to divide both of these things by cos, but you don't do that. You say that 0 will equal cos x brackets minus 2 sine x plus 1. Okay, now that gives me two equations that are quite simple. It's going to give me minus 2 sine x plus 1 equals 0, and it's going to give me that cos x equals 0. Okay. Okay, so what we need to do is solve both of these. Let's take this one first. This is the trickiest one. So if we rearrange this, we're going to get effectively that a half equals sine x. So I then do sine to the minus 1 of a half and solve that. Remember, what modes do we need to be in here? We'll put this up here. Between 0 and 2 pi, that means we need to make sure we're in radians. So then we do sine to the minus 1 of a half, which gives me a 6 pi. Okay, then I use that, remember, to get my answers. So there's your sine graph between 0 and 2 pi, because that's the domain up there. And it was positive a half, wasn't it? So it means that we have the first two quadrants. So a sixth is an answer, and then pi minus a sixth, which is 5/6 pi, is the other answer. Okay, what you now do is sub both of those back into the original equation up here to get y. So if you plug those into your calculator, you should end up with y equaling 5/4 for both of them actually. So your two coordinates there are a 6 pi 5/4 and 5/6 pi 5/4. Okay, so let's go back up to this one. If you do cos to the minus 1 of 0, you should know what that is, but you're going to get half pi. So do the same thing, sketch out your cos graph. Remember, that's the one that starts up there, comes down, and then goes back up. So the two quadrants this time are the first one and the last one, which means my first answer is going to be a half pi. My last answer is going to be 2 pi minus a half pi, which is 1.5 pi. So I'm going to write that as 3/2 pi. And then if I sub that back in, sub a half pi into there, that's going to give me 1 plus 0. Or 0 plus 1, sorry, which is 1, isn't it? So that gives me a coordinate of a half pi 1. I'm going to sub that back in, you'd end up getting minus 1. So you'll get 3/2 pi minus 1. Okay, so quite a lot of work there, but it was a 6-mark question. So can you now have a go at this one? Let's have a little look at what's going to go on there. I'll just talk you through it. Then I want you to pause the video, have a go at it, and then we'll talk through it together in a second. So the maximum point, so straight away there, you can see that that is going to be similar to what we've done up there, because a maximum point is a stationary point. So it should tell you straight away you're going to be doing the same thing up there. You're going to be getting your dy by dx and equaling it to 0, because a maximum is a stationary point. With this equation, between this domain is the point A. Show that the x coordinate of point A satisfies that equation, which means that actually there's a little bit less marks here, because what the x coordinates here were just these numbers, weren't they? The half there, sorry, the 6 pi and the half pi were only those 4 basically. I didn't need to do the second part. So what I'm going to have to do is differentiate this, set it equal to 0, and then effectively just rearrange whatever I get to make sure that it looks like this. Okay. Now the only difference here being, you are going to be differentiating obviously that sine. I'd write that as sine to the half. But you're going to have to use the product rule, because you've got a u and a v there, haven't you? Okay. I would go and differentiate sine to the half the same way that we did this one up here. Okay. And then put that into u dv plus v du. Okay, so pause the video now, please. Then have a go at it on your own, and what I'll do is I'll start to go through it step by step with you. Right, so if you've done everything you can, hopefully you should have all this written down. If not, don't worry about it. So we're going to differentiate sine to the half x the same way that we did cos 2x up there, cos squared x, sorry. So we're going to let y equal sine to the half x, and we're going to say u is sine x, which means that y equals u to the half. So dy by du is going to be a half u to the minus a half, and du by dx will be minus cos x. Will be cos x. Okay, remember that u is sine x, so dy by dx, I'm going to differentiate sine to the half x, is going to be a half sine to the minus a half cos x. Okay, and I'm going to tidy that up a little bit, because sine x to the minus a half means it's going to be 1 over root sine x. So because you've got the half there as well, differentiating sine to the half x will look like this effectively. You're going to get that's the sine, the root sine is going to be on the bottom with the 2, and the 1 times the cos is going to go on the top. So we're going to get cos x over 2 root sine x when we differentiate sine to the half x. A bit of a pain, that one. So we can now go back and do the product rule with this. If u is x, it means that du is 1. So du equals 1. And if v is sine to the half x, we've figured out over here that if we differentiate that dv, we're going to get this. Okay, so u dv is going to be x cos x over 2 root sine x plus v du. Now I'm going to write that back as root sine x. Okay, so that's what dy by dx equals. Okay, so this question involved using the chain rule within using the product rule over there. Okay, so because we know it's a maximum point, I'm going to set this equal to 0. So 0 equals x cos x over 2 root sine x plus root sine x. I'm going to take this over to the other side, so I'm going to get minus root sine x equals x cos x over 2 root sine x. I'm then going to multiply both sides by 2 root sine x, which means I'm going to get minus 2 sine x equals x cos x. And I'm at a stage now where I haven't got any roots or anything like that, so I'd probably at this point look at where I'm trying to get to. What's going on there? I've got a tan there, haven't I? I've got a sine and a cos here in my 2 terms. So if I divide everything by cos, that's going to give me minus 2 tan x equals x. And then if I bring this over to the side, it's going to give me 0 equals 2 tan x plus x. And therefore we've shown what we wanted to show. So we can, if you want to say that. Okay.